Alright, in this video we'll be looking at differentiation by first principle. So I'm going to give you the general method and then we're going to take examples. Okay, let's say we have y is equal to f of x. So the first step is to add an increment to both sides. So we're going to have y plus change in y equals f into x plus change in x. Now the next step is to subtract the original equation. So we're going to have y plus change in y minus y is equal to f into x plus change in x minus f of x. So you subtract what you have when you started. So after that, y will take out minus y, so you're going to be left with change in y equals f into x plus change in x minus f over x. So from here we're going to divide both sides by change in x. So we're going to have change in y over change in x equals f into x plus change in x all over change in x minus f of x over change in x. Alright, so because they have the same denominator, you can bring these two together. So we're going to have change in y over change in x equals f of x plus change in x minus f of x all over change in x. So after that, you're going to take the limit as change in x tends to 0. So I'll divide the x is you take the limit as change in x tends to 0 of the previous one. So you're going to have f into x plus change in x minus f of x all over change in x. So that is the general method. So now we're going to take some examples. Alright, so we have our first example here, which says find the derivative of x squared with respect to x using the first principle. So now we're going to have y equals x squared. Alright, please always put your x in a bracket. Now I'm going to explain why as we solve. So we're going to have y equals, you put your x inside a bracket, all squared. Now the next step is to add an increment to both sides. So we're going to have y plus change in y is equal to x plus change in x all squared. So from here we're going to have y plus change in y equals, square means you duplicate the bracket, so we're going to have x plus change in x times x plus change in x. So let's open up that bracket. So we're going to have y plus change in y is equal to x times x will give you x squared plus x times change in y will give you x change in x times change in x will give you x change in x. Now change in x times x is also going to give you x change in x, and change in x times change in x is going to give change in x squared. Okay, so from here we're going to have y plus change in y is equal to x squared plus, now x change in x plus x change in x is going to give you 2x change in x plus change in x squared. Okay, so the next step is to subtract the question what you started with. So we're going to have y plus change in y minus, you can see it, y equals x squared plus 2x change in x plus change in x squared minus x squared. So we have minus x squared. So that is the next step. So from here you're going to have this y will cancel out this y, and this x squared is going to cancel out this x squared. So we're going to have change in y is equal to 2x change in x plus change in x all squared. Now the next step is to divide through with change in x. So we're going to have change in y over change in x is equal to 2x change in x all over change in x plus change in x squared over change in x. Now to simplify this, we're going to have change in y over change in x is equal to change in y will cancel change in y, so we have change in x will cancel change in x, so we have 2x plus, now this is same thing as change in x times change in x, you can see it is squared all over change in x, so this will also cancel this. So at the end of the day we're going to have change in y over change in x is equal to 2x plus change in x. Now to get our dy dx, we're going to take the limit as change in x tends to 0. So we're going to have dy dx is equal to the limit as change in x tends to 0 of 2x plus change in x. Now when we say the limit as x tends to 0, what we're basically trying to say is anywhere you see change in x, put 0 there. So we're going to have dy over dx is going to be, so now we have 2x plus 0, and that's going to give us our dy over dx is now equal to 2x. Alright, I'm going to take more examples to show you how simple this is. Alright, thanks for watching, and see you in my next video.